Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about stationary random process concept. And what is stationary random process? A random process x of t is said to be stationary or strict sense stationary random process if all the statistical properties of the random process are not affected by a shift in the time. In other words, a random process x of t is said to be stationary if all its statistical properties such as mean, moment, variance, etc. don't change with time. And this is the definition of the stationary random process. For stationary random process, all the statistical properties of the random process are not affected by a shift in the time. The physical meaning of the stationary is that a translation of a sample function results in another sample function of the random process having the same probability. So depending upon the density function of the random variables of the process, there are several types of the stationary. They are first order stationary random process, second order stationary random process, wide sense stationary random process, and nth order stationary random process. Depending upon the density functions of the random variables of the random process, there are different types of the stationary process that are first order, second order, nth order, and wide sense stationary random process. First, we are going to discuss about first order stationary random process. And what is a first order stationary random process and what is its mathematical expression? If the first order probability density function of the random process does not change with a shift in time origin that is independent of time, then it is called as first order stationary random process. So that is mathematically the first order stationary random process is fx of x1 comma t1 is equal fx of x1 comma t1 plus tau for any t1 and any real number tau. So fx of x1 comma t1 is the probability density function of the random process x of t, where tau is the real number. From the above expression means this expression, first order stationary random process expression, we can say that fx of x1 comma t1 is independent of time t1. So the mean value of the random process is constant. So the condition of the first order stationary random process is the condition the condition for a process to be first order stationary random process is that its mean value must be constant at any time instant. So that is expectation of x of t is equal to constant. So expectation of x of t is also denoted as x bar. So this is the condition of the first order stationary random process. In order to prove this statement, consider two different random variables x1 and x2 of the random process at time t1 and t2. In order to prove this statement, consider two random variables x1 and x2 of random process at two time instants t1 and t2. So the first random variable x1 is equal to x of t1 and the second random variable x2 is equal to x of t2 at time instants t1 and t2, and t2 is equal to t1 plus tau. Consider t2 is equal to t1 plus tau. The mean value of the random variable or the mean value of the random process x of t is given by expectation of x of t is equal integral minus infinity to infinity x into fx of x comma t dx. So now here the random process x of t is the random process with two random variables x1 is equal to x of t1 and x2 is equal to x of t2. So the mean value of the first random variable is expectation of x1 equal to expectation of x of t1 which is equal to, for continuous case, integral minus infinity to infinity x1 fx of x1 comma t1 dx1. So similarly, the mean value of the second random variable expectation of expectation of x2 is equal expectation of x of t2, which is equal integral minus infinity to infinity x2 fx of x2 comma t2 dx2. Select the values of the random variable x1 is equal x2 is equal to x. Consider x1 is equal to x2 is equal to x. So from the above two expression, the mean value of the first random variable expectation of x1 is equal integral minus infinity to infinity x1 into fx of x1 comma t1 dx1, and x2 is equal to x, and x1 is equal to x2, x2 is equal to x. So the mean value of the second random variable expectation of x2 expression is 1. But the second time instant t2 is equal to t1 plus tau. T2 is considered as t1 plus tau. So now here t2 is replaced by t1 plus tau. We get expectation of x of t1 plus tau is equal integral minus infinity to infinity x1 fx of x1 comma t1 plus tau dx1. For a stationary random process, the condition for a stationary random process. And what is the condition for the first order stationary random process? This is the condition for first order stationary random process. So using the stationary random process, reducing the above expression, we get expectation of x1 x of x1 plus tau is equal integral minus infinity to infinity x1. So using first order stationary random process, fx of x1 comma t1 plus tau is equal to fx of x1 comma t1. So we know that expectation of x of t1 plus tau is equal to expectation of x of t1, which is equal to constant. So this is the condition for a first order stationary random process is that its mean value must be a constant at any time instant. That is expectation of x of t is equal to constant.